Library of Babel is a fictional story written by George Louis Borges in 1941. It is a fictional library which contains every possible ordering of 25 basic characters, pretty much the alphabet, the period, the comma, and space. Though the vast majority of the books in this universe are pure gibberish, the library also must contain somewhere every coherent book ever written or that might ever be written, and every possible permutation or slightly erroneous version of every one of these books. We're going to try to write a script which replicates this library, and we'll try to use large language models to find the pages which contain meaningful information. Library of Babel library actually exists on the internet. It's libraryofbabel.info. And if you read this, it says that if completed, it will contain every possible combination of 1,300,000 characters, which is in the library's description would makes about a book. But currently, in this particular website, it contains all possible pages of 32 characters, and the number of books possible, even at this scale, is incredible, 10 to the power of 4,677 books. You can actually browse this library and go to Browse and go to one of its levels and click on one of the books, shelves, and if we select the book, see, this is one of the pages. As you can see, it's completely gibberish, but the idea is that this is like 1 million monkeys typing on a keyboard. Everything is contained in this library that can be written in 410 pages and with 3,200 character pages. So to demonstrate the daunting nature of this task, let's ask for a script which generates every possible ordering of only 4-letter words using only the English alphabet, comma, the period, and empty space. Let's stop the script and print we did. We did it when one of the words is echo. So here we are getting a finished script. Let's copy this into our IDE. So this is going to use the standard Python library itertools and iterate over all these characters, including comma, empty space, and the period. And it's going to yield a word, and we're going to use this function here. Let's print all the words as they are generated so we can see. Let's run this. I have no idea how long this would take. But there you go. Oh, it starts with A and then B, C. So it's doing it ordered. That's good. Actually, E, echo. Okay, we did it. Let's see how many times it actually took. Let's take this, give it the cursor. We could have also copied it into, let's print each iteration number. Okay, let's try this. So we're actually going to print along with the iteration number so we can see at how many iterations we are reaching. So as you can see, we are already at 30,000 iterations, 40, 50. Okay, we're almost there. So echo was the 99,000th iteration, but we nevertheless found it. So as you can see, this is possible by reordering the alphabet, the comma, and this empty space and the period. We can actually create meaningful words and sentences, and at the end, entire books. The final completed script, which you can download from my Patreon, which is the finding meaning in adjacent words.py, actually allows you to enter page numbers and pick simultaneous pages to process, and processes them. And if it finds meaning, then it writes the content and the meaningful words we find, and we make a call to GPT to extract a meaningful sentence out of it, just in case if there is more than 3 words, because that's our preliminary check, and writes it to a SQLite database. So it's a pretty exciting one. I'll actually be doing a live stream on this. So I set up a live stream for the 16th at 3 p.m. Los Angeles time. Well, we should be able to go about 5 million pages unless the script crashes or something, but hope to see you there. Here's another issue with this approach. I mean, one of the limitations. Well, let's see if we were to, this is one of the pages, right? So let's roughly grab it and put it into OpenAI's tokenizer to see how many tokens each page is. So I'm assuming each page is going to be about 2,000 tokens. And since each book is 410 pages, 2,000 times 410 is roughly about 1 million tokens. So this would cost $1 to process if we were to send it to GPT 3.5. I've looked at other options too, but it's just very expensive. Let's ask GPT if we can come up with a different way of doing this. detecting meaning in Library of Babel. Let's first start by asking, do you know Library of Babel? It says, yes, I'm familiar with the concept of Library of Babel. It's a theoretical construct. So I ask, we want to generate this library in Python. How can we do that and make sure we are not regenerating random pages twice? We want to do this in an orderly manner. So since we are going to be generating at random, we don't want to generate the same page twice. So as you can see, is the key issue here is you'll face the sheer scale of the project. Library of Babel is described by Borges, contains all possible combinations. It's just astronomically high. Here we have a script which does it in a systematic manner. Let's copy this. If we paste it here, we see that we create a hash from the page string. We do use the alphabet and the required characters. Each page contains 3,200 characters. And now we join the page string. Let's print the page string. It's also going to store it into a folder. By the way, all these files will be available at Patreon if you want to play around with it. If you do become a patron, you'll have access to 200 other projects as well. So even if we were to run this for a little bit of time, it's just going to produce incredibly vast amount of data, as you can see. I'm going to stop this by killing the terminal. So we've already generated like a few hundred text files, and they are, when we generate it in a systematic way, we are only really modifying them very, very little in the end. So this would take forever, pretty much. So we need to do this differently, but I'm going to keep each one of the files if you want to play around. This was the first one with the forward characters. This is systematically generating Library of Babel. These will be available at Patreon. So to simplify this process, let's do some experiments. I just asked what is the best and fastest method to try to find meaningful words in a page from Library of Babel. I actually copied a single page from the library. What if we were to insert some meaningful word here? Is there some algorithmic approach to find if this page contains even a single meaningful word? Let's first take a look at that. Okay, GPT is suggesting finding meaningful words in a page which contains. It's a challenging task. It recommends natural language processing like nltk library or spacy. Example approach would be to tokenize the text and the words, use a dictionary to check if the tokens are meaningful words, or named entity recognition. Dictionary lookup. This is a simpler, more straightforward method. Regular expressions to check if any pattern is matching. Machine learning models. Hybrid approach. Let's write example Python code for dictionary lookup. Okay. So it recommended a code which assumes we have a text file with all English words, with the meaningful English words in it. We're not going to use that. I just asked, how can we use an LTK or space? Because that sounded interesting. So it recommended some script both for using NLTK's punct average perceptron tagger, which is going to look for nouns, verbs, and adjectives, and also spacy using these both uses models. I just asked which one would be better. It says an LTK is highly modular, flexible, performance. Spacy is designed for production faster and more efficient. Let's go with spacy then. Okay, we're just going to copy this code. We do have to pip install and download the model, but I'm just going to paste it here. We don't want to use this text. We want to load this page from the library, right? Okay, let's do this pip install spacy first. I do want to do this in my environment. Don't want to do it in my global environment. Anyway, next up is install the model, download the model. Let's go ahead and do that. Okay, while the model is being downloaded, let's say let's use Copilot, let's grab the name of this file, okay, I'm just saying open that file, and okay, here we go. Copilot is going to read it, so our text is going to be that. Can now load the model. So, okay, let's run this real quick. See, so it's supposed to find any meaningful words from this. Let's see what happens from this page, if there is any. Potential meaningful words. Oh, this is not good. Just did a bunch of gibberish words. Okay, I'm going to uninstall this, the model. Obviously, this didn't really work. It's not going to work for us because it's finding a lot of words that are not meaningful. Let's try the NLTK. We have to pip install NLTK in our environment. I'm just going to copy this, paste it here. Before we continue, instead of this random text, let's load up the our file. There we go. So this is going to download punct and average perceptron tagger. Let's run this. I've installed nltk. I'm putting them into requirements.txt. I'm keeping all the files separated if you want to try them yourselves. From Patreon, link will be in the description. Anyway, let's run this. Let's see what happens. Remember, we're looking for nouns, verbs, and adjectives. Spacy really didn't do a good job. Okay, this one is failing too. I mean, it's just picking up on all kinds of gibberish, thinking it might be meaningful. I think we might have to use a dictionary approach. The idea is that, well, let's generate a bunch of random pages and let's find ones which actually include some words that are meaningful, and then maybe put a threshold. If there is 3 or more, then send those to GPT to see if there's anything meaningful. If you're enjoying my content, check out my website, echohive.live, where you can find all my videos. There's currently almost 250 of them. And if you're a patron, you can quickly find the projects you're looking for, like the Gemini Salesperson Assistant or GPT Live Assist, and click the code download, and it'll take you to Patreon. You can simply download it, run it, use it with GPT, give it as an example, modify it. So becoming a patron in combination with echohive.live is really useful. Also check out my website, AutoStreamer, which allows you to create content and live streams automatically. It also builds course websites. And you can watch the live stream for that where I demonstrate. You can also read more about it at the Patreon shop. So I told GPT these methods didn't work well. I said, is there a library we can use which has a dictionary to detect most common English words? And it says PyAncient is a spell checking library of Python that can be used to check if a word exists. Okay, okay, this is pretty straightforward. I guess nltk also have words. There's also word frequency library. I just asked which one will be the fastest. Let's incorporate that into our script. It says word frequency library likely the fastest. Okay, let's pip install that then. I'm pip installing it, put it into the requirements. Create a new file saying try and with word frequency. So we have the library installed. Here is the code. Let's copy this. Let's paste it here. But our text is going to be what we load. So let's copy this again and replace this. Okay, let's run it. Let's see if it works. Common English words. Okay, is this really a common English word? Yeah. Okay, let's try a different one. So I asked, let's try with PyAncient instead. Let's only look for meaningful 4-letter words, because obviously it's gonna like A might be a meaningful word, D might be a meaningful word, right? Apparently it thinks D is a meaningful word. So we need to add PyAncient to our requirements. Let's copy this as well. Let's install it. I'm installing all these in a separate environment. Just be mindful of that. Okay, this is our script. Let's copy this here. Made a new file, pasted it here. So it's going to check for 4-letter words, find meaningful words. Of course, we need to load our text from the file. Okay, let's run this. Okay, meaningful 4 letters found, 0. That's good. So what if I were to put hello here and then run it again? Meaningful 4-letter words, 0. Maybe I have to save it. Let's try again. Oh no. Oh, okay. So wait, so we were only checking for 4-letter words, equals. We want it to be greater or than equal to 4. I've actually changed the hello to world. So this should work. Hopefully, fingers crossed. Yeah, world. Okay. So if we try hello again, it's going to find it, right? Yeah. So this is good. But what if this was like that? It's going to, because it's using word splitting, is it going to work? No. So it's only going to work if the word is separated with a space, which might make sense, I suppose. Let me think about it. Okay, I asked if we check for words when they're not separated by spaces. We want to check for words that are 4 letters or more. So it says that this is going to be computationally expensive, and obviously this whole thing is computationally expensive. Should we do this? Well, let's try it. Okay, so our hello is not separated with a space, and this is supposed to check all the substrings. This is already taking too long. Look at it. It's hanging up. It's already been like half a minute. It's still running. Just ask Cursor if this code correct. It says logically correct. I don't see an issue with it. It's still running. It's been over a minute. So this is not going to be a viable approach. Nested loop approach is not very efficient, obviously. So, okay, we're ditching this one. Kill the terminal. Go back to the original. This one works, but only works if the words are separated with spaces, but that's fine. Okay, so we're just going to look for those. Okay, so let's make this create random pages, not systematically, but just random pages from alphabet and a space and a comma and a period. And let's check for, instead of a single page, let's check each one of those pages and then let's save them, perhaps to a SQL database. But let's save them to files. No, let's not. Let's actually save, let's see. So in my cursor, I'm going to refer to this file. I may create a new file and copy pasted the ancient Pi ancient code. I'm going to refer to it by typing its name after an @ symbol and then write some instructions. Okay, I asked, let's use this code to find meaningful pages in Library of Babel. Let's create pages of Library of Babel with 3200 characters each, then check them with Pi ancient to see if any contains 3 meaningful words, or more, I should have said. Or more. Okay, so let's stop this. It might misunderstand us. We're going to rerun this then. 3 meaningful words or more. If so, then let's save it to a file within a folder called Meaning in Library of Babel. Let's make sure each saved page has a unique file name. Let's run this again so we get any page that contains 3 meaningful words or more. Okay, it gave us some code which is using ASCII lowercase and generates 3200 length pages, but I include the comma and the space as well. So it gave us this code instead. Okay, so it's going to use ASCII lowercase plus all these 3 characters. It's going to choose randomly from each one. Let's run this with, we're going to generate a page here, characters. Let's put a breakpoint here and print the page. Let's run it with F5, the debugger. Okay, let's see what characters we're using. Okay, we're using the alphabet. That's good. And here's our page. Printed. This is what we're looking at. That's good. And of course, let's do the check as well. Find meaningful words. And there's no meaningful words found. If you do find them, then it's going to hopefully write it into a folder name, meaning in Library of Babel. And then it's going to write a random file name with get rand bits from random. So let's run this for a while. Let's see what happens. Let's actually put let's say x equals 0 and then print iteration number. And then here, let's also print meaningful words and increase the x. So if you run this, we are printing the page too. Let's not do that. Let's stop this. Let's no longer print the page, just the iteration numbers. Let's see how quickly we're going. Let me stop this meaningful words found. Oh, but we're checking, so it's finding the meaningful words. But we are checking here if any of the meaningful words is larger than. So therefore, let's move this. Let's actually move it here. Now, if we run this, we're only going to print. Okay, I just realized we're no longer checking for 4 word or more meaningful words, which we need to do right here, I believe. Let's instruct GPT to fix this. I'm just going to insert this in the chat and give it instructions. I said we only want to detect meaningful words that are 3-letter or longer. Because right? So there's a lot of meaningful 3-letter words. That's good. So all we have to do is just change this, I believe. Let's copy this, find meaningful word. Okay, now if you run it, we should, yeah. Okay, so it's just going to run. This is still very slow, as you can see. Oh, it found something. BSKIP. And we saved it. Look at that. Oh, because these were from before. Let's rerun this. Delete this folder. Rerun our script. Okay. Currently our folder is empty. Okay, we found one. let's go back here. This included non-PE and PE, so it detected that as meaningful words. Let's also create a file to test GPT to find meaning. Let's see if GPT actually can figure out, because that's going to be another one of the challenges, if we can find the meaningful sentences within a page. So I'm going to grab the basic call to GPT from my Everything GPT API course. The link will be in the description. This is available to patrons. Let's paste this here and I'll do some modifications. Change the model to 3.5 Turbo 1106. So adjusted the system message, so you'll be given a page from Library of Babel. Your task is to identify if there's any meaningful sentences, then return true, and sentence is a JSON object, required JSON format. Is meaningful going to be a string, can be true or false. Meaningful sentence is string, sentence that is meaningful. We also need JSON mode, so I'm going to grab that again from Open my GPT API course. Here is JSON mode. I just need to add this. Let's go ahead and add it. And now we are getting the response. Let's convert this to a function. Let's add it here and give some instruction. Say convert this to a function which takes in text as a parameter. So it got rid of the system message. So I said keep the system message, insert text as the user message. Let's see how it does now. Okay, this is better. So this should work. I think we're going to load the text, of course, from file, just to test it out. Just change the user message to a string, page from Library of Babel, and we insert the text. Now we just need to load the text from the file. Let's go ahead and do that. Text to analyze, file.read. Let's run this real quick. Okay, it said is meaningful false. Because this didn't really contain any meaningful sentence. What if we say hello world and try with that? So it didn't detect hello. Okay, even with hello world, it said it couldn't find any meaning. Let's try again. So this is not a good sign, because I was even hoping to use Mixtral maybe for this to make it cheaper, but even 3.5 Turbo 1106 can't find it. Let's try with GPT-4. Okay, we're trying with GPT-4 1106 preview. Okay, GPT-4 was able to detect it. And meaningful sentences, hello world. Let's see if it can actually do it just with hello. Yeah, it was able to do that. What if it was combined? I mean, without any space. So we just have a single meaningful word in here. Okay, return some gibberish as a meaningful. Let's modify the system message. So I just changed it if there's any meaningful English sentence. Let's run it again. Okay, good. It returned hello, even when it is not separated by a space. Let's run it a few more times. Okay, again, it returned hello. Let's run it one more time. So this is why even 3.5 can't do this task. I wonder if Mixtral or Llama would be able to do it. Maybe I'll experiment at the end. Okay, it again found a hello. That's a good sign. I'm curious, actually, let's try with Mixtral using Open Router. So I'm just going to copy some code, paste it here so I can assign it. Let's just put it up here. Get the API key, place the model with Mixtral. Okay, I have to get the OR API key. It should work, I think. Let's try real quick. Oh, we probably can't do the response format. That's why we got an error, I think. Okay, I was getting some errors because I was reinitializing the client with OpenAI. Anyway, once I removed it, I did get true and a meaningful sentence. Obviously, Mixtral cannot do this. Let's run it again. So this is why I guess we can really only use GPT-4 for this task. Yeah, again, it finds meaning where there is not. So, okay, we'll scrape that idea. I'll still keep this code separately. I'll create a file. Yeah, I put it into a different file if you want to test it out yourselves. Make sure to get your environment variable. I just set OR API key. Just modify it as necessary. Let's just go back to GPT-4 because that's the only one that's going to be useful in this case. So now we have a working system with PyEngine that finds meaningful four-letter words, but it finds it just anywhere in the text. We probably want to do some optimizations like parallel processing and only find the meaningful words that are adjacent to one another if that is computationally feasible. And now we want to combine this GPT call with our PyEngine code to make sure we also do a check with the GPT as well, maybe before saving. and maybe a better option of saving, maybe to a database. So I'm going to go ahead and do those changes, but the rest of the video will be available at Patreon. I'll put the link in the description. You can access both the code files and the rest of the video with that link in Patreon. Thank you for watching. Do let me know what you think of this project, if you find it exciting. If this video gets over 100 likes, I will make that full video available in my YouTube as well. Thank you for watching, and I'll see you in the next video.